Hi there. Okay, so I am excited because I think that besides giving you a little video on how to prepare and set up the lab, this is the last lesson video for chemistry and for the whole semester. And I'm excited. I hope you are too. And you've done it. Oh, I'm so proud of you guys. Okay, acids and bases. You've already You've watched the two videos from Brain Pop, okay? So they give you an overview of how pH works and the difference between acids and bases. And now we'll just put some notes down in our booklet that we can use to come back and refer to, okay? So this is on page 10, okay? So it says acids are substances that produce hydrogen ions, okay, in a solution. So that would look like H with a little plus, because that tells me it's an ion, and it's in a solution, so AQ, okay? Now, hint. Compounds that begin with H, okay, are normally acids. So not only do you not have to do a test all the time, but you can quickly see if something is going to be an acid or not, okay? Bases are substances that produce hydroxide ions, okay, in solution. And hydroxide has the formula OH, and the charge for hydroxide is negative. And if it's in a solution, AQ again, okay? So, and the hint for bases is compounds that end in OH are normally bases. Okay, we're done. So that gives you some quick tips, okay? Now, what are some characteristics of acids and bases? So from that video, it talked about how acids are sour tasting, okay, but don't go around drinking them all, okay? That could be really dangerous, okay? They produce hydroxide ions, okay? They turn, you're gonna see this right away, they turn blue. Litmus paper red. Okay. They have a pH between 0 and 6. And they also react with metals to produce hydrogen gas. Okay, which you would have discovered doing the Explore Learning assignment on the different chemical reactions, okay? Now, what about bases? What kind of stuff did we learn about bases? Well, bases are bitter tasting, okay? They produce hydroxide ions. Okay, so I should probably put that in brackets too, because the negative charge applies to the whole thing, not just the hydrogen. Okay, they turn red litmus paper blue, and they have a pH of 8 to 14. Right. And what do we know about both of them together? What kind of commonalities? Okay, they can both be clear or colorless solutions, and that's what makes them really dangerous. You don't know if you're dealing with a weak acid or a weak base or a strong acid or a strong base. They can all look like water, okay? That's why we're going to learn how to do some tests at home on just regular household stuff to be able to see how dangerous they are, Okay? Okay, so it can make any liquid dangerous. Okay. So turn the page and let's take a look at the pH scale. Okay, so like the video said, the pH scale measures acidity, okay, or basicity. That's not a word I'm able to say very well. Basicity, okay, of solutions. And the pH scale is measured from the pH from 0 to 14. Okay, we know that anything less than a 7 is going to be an acid. Anything that equals 7 is neutral. And anything greater than 7 is basic. Okay, and sometimes you'll hear the word alkaline. I'll write that too, alkaline. Okay, that means the same thing as a basic. Okay, think alkaline batteries, exactly. Okay. Very high and low pH solutions are harmful. Okay. Water is neutral because the hydrogen and hydroxide ions balance. Okay. So I think of it like this. So think hydroxide has a negative charge, and if I add my hydroxide ion, negative plus a positive is 0. Okay. So now this doesn't do a very good job with color, but on the Brain Pop video it showed you the kind of different degree, but I like this because it gives us a bunch of examples of what would be considered a base and what would be considered an acid. Okay, turn the page. Indicators. Okay, so I love indicators, and we have a ton more at school that we can use to test stuff out, but I gave you 3 to test at home: blue litmus paper, red litmus paper, and pH paper. Okay, so indicators are substances that change color as the concentration of hydrogen or hydroxide ions changes, and they indicate pH. Okay, so for example, we have litmus paper, phenolphthalein, which is the 0, or which is like the pink solution that you'll see them dip in on videos to show, oh, this is human blood. That's what they're using. Okay, universal indicator, blue. Oh, and there's tons more. Okay. Blue litmus paper turns red, it's an acid. Okay, so I think of the acronym BRA, B-R-A. Okay, blue turns red, it's an acid. Okay, when red litmus paper turns blue, it's a base. Okay, so think RBB. Okay. Red turns blue, it's a base. This one I always remember, easier because it's an actual word, okay? And then I just know the opposite would be true for the base. Most indicators work over a short range of pH values, okay? So if the pH goes from, oh, sorry, that's 7, 0 to 14, okay? Litmus paper tells you if it's an acid or it's a base, but pH paper will tell you very specifically what type of pH it is, and things like universal indicator will give you general areas. Okay, so you'll be able to narrow down what the actual pH is by using a bunch of different indicators.
Ryan Vogt, could you phone Bob on his cell? Ryan Vogt, call Bob on his cell.
Okay. So in the bottom here it says that too. The universal indicator or pH paper contains a number of indicators that change color all at different types of values. Okay, turn the page. Last page. Right on. Reactions. Okay. Metals react with acids to form hydrogen, gas, and a salt. Okay, and you would have seen this too when you were doing the chemical explore learning thing. There's quite a few reactions that had this, and you were able to see this in the products. Okay, so for example, magnesium, when we add hydrochloric acid, produces a gas and magnesium chloride salt, MgCl. When you have a metal and Cl, okay, this is a salt. Okay, the acid reacts with bases to form water and a salt. This process is called neutralization. Okay, that's key. Okay, so when we take in acid and we mix it with a base, we're able to neutralize it so that it can be poured down the drain. So if we have a strong acid solution, we're going to add a strong base to it so we can bring it down to 7. Okay, so for example, hydrochloric acid, when we mix it with sodium hydroxide, which is a base, notice here, OH, that tells us it's a base. Notice here it starts with the H, okay, it's an acid. And what does it make? Well, NaCl, that's our salt, and water, okay? It can make lots of different kinds of salts, but it'll always be a salt and a water, okay? And what type of reaction is this? Of the 4 different types of reaction that we have learned about, this is a double displacement reaction. Awesome. Okay. And that is it. That is all we need to know for acids and bases. Okay. And the last thing we'll be looking at our lab, and I will talk to you about that in our next short video. Okay. Off you go.